Cześć. Well, that's the way we say hello in Poland. Hello, children. How are you people doing? I'm Saurabhkumardutt, and I'm here to teach you people a little bit of mathematics and also to make your mathematics strong. I'm sure you people must be wondering what this majestic building is. This is the Malbork Castle on the eastern bank of the river Nogat, Malbork City, Poland. This is the world's largest castle, built in the 13th century by the Teutonic Knights. It was the seat of the Grand Master of the military monks. Do visit this awesome place. Have a nice time here, but do remember to have the great Polish food, pierogi, and also to wish all the people of Poland that you get to meet, cześć. In this note, children, I'm going to start off this lecture of exponents, which is also known as indices, normally in the syllabus of class 9 in the different boards. Now here, children, there is a pattern which you require to follow to understand all of these lectures. The first is make sure you are sitting at a secluded place so that there is no disturbance. Then you require to sit on a table and chair straight such that you're able to understand and follow everything, right? And then pause the lecture, write the notes, also practice the sums once so that everything becomes perfect in your knowledge, right? Now, children, one thing more. Here we will be discussing a little of the lecture, and the rest of the lecture you can follow by clicking on the link which is there in the description or in the first comment after this lecture. So make sure, children, you watch the complete lecture and have a good grip over exponents. Let's get started, children, and let's understand what an exponential form is and where we encounter exponents. And after that, we'll be looking up a few formulae and also a few sums. Now, children, first we will be discussing about what the exponential format is. So if suppose we have a number multiplied by itself a few number of times, we call it to be the exponential form. For that matter, let's say we talk about 4, which is getting multiplied with 4, say 3 times. Then we can write this as 4 raised to the power 3. Right? So here, what did we do? If we had 4 multiplied to its own self a specific number of times, then we write 4, and in the superscript or in the superfix, we write here number 3, right, which shows how many number of times this number 4 is to be multiplied with its own self. Now, generally speaking, we can write this as some a which is raised to power x, right? You got to remember here that whenever we talk about this a is the base, right? And if we talk about the number which is in the superscript or in the superfix, we call it to be the exponent, or we can even call it to be the index, and in certain cases it is also said to be the power. So these are the different synonyms that you can have for this number which has been written in the superscript. Like I told you earlier, if we have a raised to the power x, it normally means that a will be multiplied to its own self x number of times. For that matter, then x should be an element of integers. But generally speaking, if we talk about this a is to be any number which is from the set of real numbers but is to be positive, right? So these are two very important factors about a that you should remember. That the first is that a should be greater than 0, that is, it should be a positive number, and it can be any number, rational or irrational, from the set of real numbers. The next thing, children, is that if we talk about x here is to be a number or is to be a variable whose value is to be found such that it can be an element of real rational numbers, right? So if we talk about this x has to be from the set of rational numbers, and as rational numbers is represented by capital Q, so this is what we'll say that x belongs to, or x is an element of rational numbers. So all of this that I told you people, I'm going to repeat quickly. The first thing is, when we talk about this chapter, which is known as indices, or which is also known as exponents, here we will study about a number being multiplied to its own self. So if we have a number 4 which is multiplied to its own self 3 number of times, we can write this as 4 raised to the power 3, where 4 becomes the base, that is the number which is being multiplied to itself, and 3 is known as the index, the exponent of the power, which gives you how many times the number will be multiplied to its own self. Now generally speaking, we write this as a raised to the power x, where a is the base and x is the exponent or the index or the power. And we also have to say here what are the limitations for a. For that we have some rules, that is, a is to be a number which for sure has to be positive, right? And a is to be a number which is to be an element of real numbers, right? So when we talk about both of these facts, then that is the condition for a. Now if a is to be a negative number, then what will happen is we will have this number to be a complex number, and that is why, because we normally want to study about real numbers, that's why we talk about a to be a positive number, right? Now if we talk about x, remember, has to be from the set of rational numbers, be it positive, be it negative, it has to be from the set of rational numbers q, right? So these are few facts about indices which you should know before you start applying about indices. Now after this, children, we will be talking about the few of the rules that we have in applying on sums of indices. So when we talk about the rules, the first is this, that if suppose we talk about a number which is raised to 0 power, then that will become equal to 1. So any number which is raised to 0 power will become equal to 1, right? So this is the first rule. Then the next rule is this, that if we have a into b, which say will come to a number c, say, and if say it is multiplied an m number of times, or in other words its power is m, then this will give you a raised to the power m multiplied with b raised to the power m, right? So the number a is multiplied to another number b, right, and the whole power of this is m, so this will give you a raised to the power m multiplied with b raised to the power m, right? Now next after this is the rule, that is, if you have a raised to the power m which is multiplied with a raised to the power n, then that will become equal to a raised to the power m plus n. That means if there are two numbers which are multiplied such that their bases are the same, then the indices will be added whether they are equal or unequal, right? Next, children, after this we have the next rule, that is, if say we have a raised to the power m which is divided by a raised to the power n, then this will be given by a raised to the power m minus n. This rule is that if you have two numbers which are such that the first number divides the second number, right? The second number divides the first number, then if their bases are the same, then keeping the base to be the same, in the exponent you will have the difference of the number which is there in the numerator's power minus the number which is there in the power of the denominator, right? So a raised to the power m divided by a raised to the power n will become equal to a raised to the power m minus n. After this, children, we have another rule, that is, if we have a raised to the power m which is whole raised to the power n, then that will become equal to a raised to the power m into n. Or in other words, if we have a number, right, which is in the exponential form, and if suppose the whole power of this number is n, then this will become, keeping the base to be the same, the exponents of the indices will be multiplied to each other, as such the power of the number will become equal to mn. Now quickly, children, all of these rules I will tell you all over again, so that if there is any doubt, all of that will become clear. And like I told you earlier, you will pause the lecture and write all of these rules, rewrite it for better understanding, and after that you will proceed with the lecture. So first, children, when we talk about the rules which are there in indices, we have a raised to the power 0, which becomes equal to 1. The next is we have a into b, which is whole raised to the power m, will give you a raised to the power m into b raised to the power m. Next is when we have two numbers which are multiplied so that both of these are in the exponential form and their bases are the same, that is a. So keeping the base to be the same, the indices will be added. Next, if there is a quotient of two numbers such that both the numbers are in exponential form and their bases are the same, so keeping the base to be the same, you will subtract from the power of the numerator the power of the denominator, right? Now next, if you have a number which is a raised to the power m in the exponential form and its exponent is n, then this will be a raised to the power the product of the exponents, that is keeping the base to be the same, the exponents will get multiplied, right? So these are few rules that we use in indices. I'm sure you must have understood all of this and you will write all of this, learn it, and then come to the sums. Okay, children, now after a good vivid description of all of this, we will now come to certain sums. The sum that I have for you people at this time is this. I will give you a little time, say some 10 seconds for trial, after which we will be discussing the sum. Right, now let's discuss the sum, children. Here we get to see that we have to simplify a quotient that we've been given, that is a numerator divided by a denominator. So here what we do is first we bring all of these numbers which are in the power format or which are in the exponential format such that they are some numbers which are such that prime numbers raised to some power, they can be converted. Like suppose if we talk about 25, it can be written as 5 raised to the power 2. So this is what we're going to do here. So we will write here 5 into 25, which can be written as 5 raised to the power 2, and its whole power will become equal to n plus 1, minus 25 can be written again as 5 raised to the power 2, and dot means it is multiplied with 5 raised to the power 2n as has been given to you. And for the children, next now in the denominator we have 5 which is multiplied with 5 whole raised to the power 2n plus 3, that means it can be written as 2n plus 3, right? And minus again this 25 can be written as 5 raised to the power 2 whose whole power is n plus 1. Now children, here we are going to use certain rules, that is if we have a raised to the power m which is whole raised to the power n, then we know that that will going to become equal to a raised to the power m into n. And now we're going to use this. So here we have 5 which is multiplied with 5 raised to the power. Both of these powers in accordance with this rule is going to get multiplied, so we will have 2 times of n plus 1 now. And then further we have 5 square which is multiplied with 5 raised to the power 2n is what we can write here. Next children, if we talk about the denominator, in the denominator we have 5 which is multiplied with 5 raised to the power 2n plus 3. So if we have it to be 5, obviously the power of 5 will become equal to 1. And now children, we can use another rule, that is if we have a raised to the power m which is multiplied with a raised to the power n, then that will become equal to a raised to the power m plus n. So here the powers will get added, and thus we will have this to be 5 raised to the power 2n plus 3, to which 1 is going to be added, and from that is going to be subtracted using the first rule that we discussed just now, that is 5 raised to the power 2 times of n plus 1 is what we're going to have. Now for the children, here we're going to write this as 5, right? That is the power of 5 is going to be the product of 2 with n plus 1, that is 2n plus 2, to which the power of 5 which is 1 is going to be added, right, using this rule just now, that is if the bases are the same, so we can add the indices. So that's why the indices have been added here. Next now children, after this we have minus 5 square and 5 raised to the power 2n. So obviously both of these powers can again be added as 5 raised to the power 2n plus 2. And in the denominator children, we have here 5 raised to the power 2n plus 4 which can be written, and minus we have 5 raised to the power 2n plus 2. Now as we've got to simplify, we've got to try out something common in the numerator and the denominator, right, so that they can be cancelled off. Now if you talk about the first term, it will become 5 raised to the power 2n plus 3, right, and the second is 5 raised to the power 2n plus 2. Talking about the denominator, in the denominator we have 5 raised to the power 2n plus 4 minus 5 raised to the power 2n plus 2. So children, here as you can see, we can write the numerator as 5 raised to the power 2n, right, and to that we can add 2 plus 1. Why so? Because we find that 5 raised to the power 2n plus 2 can be taken common from the numerator. Minus 5 raised to the power 2n plus 2 is already there in the second term, and in the denominator we can write this as 5 raised to the power 2n plus 2 plus 2 and minus 5 raised to the power 2n plus 2, right? So in the next step, what we do is, here we take this as 5 raised to the power 2n plus 2, right, into 5 raised to the power 1, which is just the reverse of the last rule that we studied here. That is, if we talk about a raised to the power m plus n, it can be written as a raised to the power m into a raised to the power n. So here also we've done just the reverse. That is, we've written this as 5 raised to the power 2n plus 2 into 5 raised to the power 1, which will eventually get to this, right? However, this is of our benefit, that's why we've done it. And next, now after this, we have 5 raised to the power 2n plus 2, which we will let it remain as it is, which in the next step is going to be taken common. Then we can write this as 5 raised to the power 2n plus 2, right, which is multiplied with 5 raised to the power 2, which is just like as we did in the first term of the numerator, and minus 5 raised to the power 2n plus 2 will remain to be as it is. Now children, here we get to see that we can take 5 raised to the power 2n plus 2, which is exactly the same number common in the numerator. So here we will have 5 raised to the power 1, that is 5, and from that 1 is going to be subtracted because 5 raised to the power 2n plus 2 has already been taken outside. Next, in the denominator, again we can take 5 raised to the power 2n plus 2 common outside, then we'll be left out with 5 square, that is 25, and in the second term nothing is going to be left, so we will just write the multiplicative identity, that is 1. Now children, here we get to see that 5 raised to the power 2n plus 2 is common in the numerator and in the denominator will get cancelled, and then in the next step we can write 5 minus 1, which is 4, and in the denominator we write 25 minus 1, which is 24. Now for the 4 cancels 24 6 times, so 1 upon 6 will become the final answer, right? So children, now I will just quickly discuss all of this all over again. In the question we've been given here that we have to simplify an exponential expression, and that is 5 times of 25 raised to the power n plus 1 minus 25 times of 5 raised to the power 2n divided by 5 times of 5 raised to the power 2n plus 3 minus 25 raised to the power n plus 1 is to be simplified. So here what we do is, first we write all of these numbers such that it is some prime number raised to some power, right? So here I'd like to tell you one thing, that if suppose we have a number like 36 which is raised to the power 10, so this can be written as, here 6 into 6, 6 can obviously be written as 2 square into 3 square, right? So we'll have 4 into 9, that is 36, and now this number has been written as a product of the prime numbers, and thus this can very easily be simplified, and its whole power is 10, so we can write this as 2 raised to the power 2 into 10 into 3 raised to the power 2 into 10, or in other words we will have 2 raised to the power 20 into 3 raised to the power 20. So either we can take common with such numbers which have some powers of 2, or we can cancel off if we have in division some powers of 2 or some powers of 3. So doing that becomes very simple. So if we have some number which is raised to a power, then that number has to be written in terms of the product of some powers of prime numbers, right? So this is what we've done here. We've written this 25 as 5 square, right? Then children, we have this rule: a raised to the power m whole raised to the power n becomes equal to a raised to the power m into n. So as such here, this 25 which was written as 5 square as its whole power is n plus 1, so it will become 5 raised to the power 2 times n plus 1, which in the next step can be written as 5 raised to the power 2n plus 2, right? Next here, similarly, this 25 is written as 5 raised to the power 2, right? And this 25 is also written as 5 raised to the power 2, and their powers are multiplied using this rule, right? So next step now, we simplify all of this using this rule, that is a raised to the power m multiplied with a raised to the power n will become equal to a raised to the power m plus n, right? So thus here we have 5 raised to the power 2n plus 2 plus 1, right? That is 5 raised to the power 2n plus 3. Similarly, this becomes 5 raised to the power 2n plus 2. In the denominator, we have 5 raised to the power 2n plus 3 plus 1, that is 5 raised to the power 2n plus 4, and minus 5 raised to the power 2n plus 2, right? So here in the numerator and in the denominator, we get to see that 5 raised to the power 2n plus 2 can be taken common from the numerator and the denominator and simplified off, that is cancelled off. So that's why we can write this 5 raised to the power 2n plus 3 as 5 raised to the power 2n plus 2 plus 1. Similarly, this is already 5 raised to the power 2n plus 2, so we will let it remain as it is. And in the denominator, we have 5 raised to the power 2n plus 4, which can be written as 5 raised to the power 2n plus 2 plus 2, right? And the second term is already 5 raised to the power 2n plus 2. Now if you talk about this 5 raised to the power 2n plus 2 plus 1, so we can keep this in one horizontal bracket, right? Similarly, this 5 raised to the power 2n plus 2 in a horizontal bracket, and then we can write this as 5 raised to the power 2n plus 2 multiplied with 5 raised to the power 1, and in the denominator we have 5 raised to the power 2n plus 2 into 5 square, right? Now children, further we can take 5 raised to the power 2n plus 2 as it is in multiplication common outside, and since it is in multiplication, we can cancel it off from the numerator and from the denominator. Now in the numerator, we are left out with 5 minus 1, and in the denominator we are left out with 5 square, that is 25 minus 1. So that will then become equal to 4 upon 24, where 4 will cancel 24 6 times, so 1 upon 6 will become the final answer. So are all of you people clear about this? For sure? Shyam? Good. Now children, the rest of the lecture you will be able to find out, which is a really interesting part of this lecture, which will strengthen your knowledge of exponents or indices in the app, the Mathematics Helpline. So do visit it, and it's very easy to visit. The link to the app has been provided to you in the description or in the first comment, right? Just click on this and reach the Mathematics Helpline to look up the rest, where I'm sure you will get such a lot of other things which will be a help to you in your study of maths, be it of any level, right? So bye children, and have a nice time. Bye. Okay children, now let's continue the lecture and quickly complete this next sum. Initially, I will give you people a little time for trial, and after that then we'll be discussing the sum. Right. Now children, let's discuss the sum. Here in the question we've been given that A is x into y raised to the power p minus 1, B is x into y raised to the power q minus 1, and C is x into y raised to the power r minus 1. So we've got to prove this expression. In order to prove this, what we do is, here now we write this as keeping the value of A, as A is xy raised to the power p minus 1. So in place of A we will write this, that is x into y raised to the power p minus 1, which is whole raised to the power q minus r. To this is multiplied b raised to the power r minus p. Now b is what? B is here x y raised to the power q minus 1, which is whole raised to the power r minus p. Next now children, we have C, which is x y raised to the power r minus 1, and now this is to be multiplied, rather whole multiplied with p minus q, as p minus q is the index. Now the product of all of this has to be shown to be 1, so at the moment we are going ahead with the left hand side, which is more manipulative, and we will bring 1 with it to show that this is true. Now children, here as we have this rule that if we have say some a into b which has a whole power of m, then that becomes equal to a raised to the power m into b raised to the power m. So as such, here using this rule, we will now have the power of x to be q minus r, and the power of y also to be the same, that is q minus r, but as there is p minus 1, so it will be multiplied with q minus r, right? Next term, we will have here x raised to the power r minus p into y raised to the power q minus 1 times of r minus p, which obviously is because we have this rule here that if we talk about a raised to the power m, which is whole raised to the power n, then that becomes equal to a raised to the power m into n. So here as such, using this now we have this. Then after this we talk about the third term, which is x raised to the power p minus q is what we have, into we will have y raised to the power r minus 1, which is multiplied with p minus q due to this second rule that I discussed. Now next children, here what we will do is we will apply this rule here, that is if we have a raised to the power m which is multiplied with a raised to the power n, then that will be written as a raised to the power m plus n. So thus here we will talk about the multiplication of all of these terms which are x raised to some power, and thus as they are in multiplication we will keep the base to be the same and we will add the indices, that is q minus r, right? Similarly we have r minus p, and similarly we have p minus q. So next now what will happen is we will talk about the powers of y. The power of y, we will find out the product. So we have pq and minus, we have pr, then we have minus q, and we have plus r here. Similarly when we talk about the power of y next, so the power of y next similarly will be qr minus pq minus r, right, and plus p, and again we will have the power of y to be pr minus qr minus p plus q. Now as again all of these are powers of y which are all in multiplication, so that's why what we'll do is we'll keep y to be same, that is same base, and we will add the powers. Now for the powers of x, we get to see that we have powers which are additive inverse of each other, so they will cancel each other. That means plus q minus q will cancel each other, minus r plus r will cancel each other, minus p plus p will get cancelled, and thus we will have x raised to the power nothing or 0, right? And then we talk about the powers of y. Keeping y to be the same base, we will add all of these powers. So we have pq minus pr minus q plus r plus qr minus pq minus r plus p, right? And to that is going to be added plus pr minus qr minus p plus q. So here children, we will cancel off the additive inverses again. So plus pq will get cancelled with minus pq. Then we have minus pr which will get cancelled with plus pr. Then we have minus q which will get cancelled with plus q. Then we have plus r which will get cancelled with minus r. We have plus qr which will get cancelled with minus qr. Then we have plus p which will get cancelled with minus p, and thus we have the cancellation of all of these terms. And again we can say that we have here x raised to the power 0 which is multiplied with y raised to the power 0. As we know here that any number raised to the power 0 is 1, and thus we can write this that we have x raised to the power 0 which is 1, which is also multiplied with y raised to the power 0, that is also 1. So the product of both of these is 1, and that children is the same as the right hand side, and therefore this stands to be proved. right? So I'll just quickly discuss this all over. In the question, children, we've been given here to prove if we have a to be xy raised to the power p minus 1, b to be x into y raised to the power q minus 1, and c to be x into y raised to the power r minus 1, and we have to prove a times of q minus r into b times b raised to the power r minus p, and this dot is actually multiplication sign, that is times of c raised to the power p minus q, and their product is equal to 1. Now next here what we do is we keep the value of a, which has been given to us, whole raised to the power q minus r. Similarly, we have the value of b, which is this, whole raised to the power r minus p. Similarly, we have c to be this, which is whole raised to the power p minus q. So we've just kept the value of a, b and c as has been given to us. Now children, we use this rule that if we have the product of two numbers whose whole power is some other number, then the number will become the product of both the numbers raised to that same power. So this is what we have to do. So we have the power of x to be q minus r, and the power of y will become p minus 1 times of q minus r, because if we have a raised to the power m, which is whole raised to the power n, then that will become a raised to the power mn, right? So that's why the power of y will become p minus 1, which is already there, times of q minus r, which is the whole power. And the same will apply to the other two brackets also, that is the power of x will be r minus p, the power of y will be q minus 1 times of r minus p, and the next will be the power of x to be p minus q, and the power of y to be r minus 1 times of p minus q. Right? Now for the children, we have to simplify all of this. Now remember here that we have a raised to the power m into a raised to the power n can be written as a raised to the power m plus n. So as we have these three x's whose powers are these, so keeping the base x to be the same, we can add the powers, and for y we will simplify all of this by multiplication. So that's what has been done here. We've done the multiplication and we've got these powers, and again we will apply the same here. As these are numbers which are in multiplication in the exponential form, we will keep the base to be the same and we will add the indices. When we add the indices, we get that these numbers are all additive inverse of each other and they get cancelled as was for the powers of x. Now children, we get the power of x to be 0, the power of y to be 0, and thus as we know that a raised to the power 0 or any number raised to the power 0 is 1, thus we have here 1 into 1 or 1 to be the final answer. And as this is what you are required to prove, therefore you can say that this is the same as right hand side, and therefore this stands to be P or proved. Make sure you write proved and not P. So are you all clear about this? For sure. Now, are you getting some strength in maths? That's good. That is the reason why I am here, and I'm always there to help you out. So do practice, and bye for now. Bye.